amid the quiet darkness of the cosmos, where light drifts as slowly as the breath of time, we begin a rare journey, an epic journey to our closest stars. Out there, the neighboring stars are not just distant points of light, but gentle companions, whispering stories billions of years old. This video promises to guide you through a voyage both tender and profound, where science becomes a soft murmur, and every discovery folds open another layer of wonder. If you cherish floating moments in space and wish to keep hearing the universe speak, a like and a subscription are like a light touch upon the sky, a signal that you are still listening. And so, we wonder, what are the closest stars to Earth truly like? The night sky has always felt like a quiet invitation, a soft reminder that we live inside something far greater than the boundaries of our little world. When we lift our eyes toward the darkness, we are not simply looking outward. We are looking backward in time, gazing across a sea where every point of light is a memory suspended in the deep. And among those countless lights, there are a few that sit closest to us, not neighbors in any earthly sense, but cosmic companions, drifting through the same galactic tide. As the astrophysicist Carl Sagan once whispered, we live on a mote of dust suspended in a sunbeam, and when we consider the nearest stars, we begin to understand just how delicate, how astonishingly rare our place in that sunbeam really is. The stars nearest to Earth are not the blazing giants most people imagine. They are small, humble, often invisible to the naked eye. They whisper rather than roar. Proxima Centauri, the closest star beyond our sun, glows not like a beacon but like a fading ember. A quiet, red dwarf, barely mustering enough light to be seen even through powerful telescopes. As the astronomer Roberto Mendez once noted, the nearest stars are not the brightest stars. They are the most honest ones. And truly, these diminutive suns offer us an honest map of our galactic neighborhood. When we study them slowly, gently, with the patience of someone listening for a distant echo, we begin to sense the immense tapestry that surrounds us. Proxima's flaring heart, Alpha Centauri's warm, familiar glow, Barnard's star sliding silently across the sky. Wolf, 359, barely there at all. These stars are more than coordinates. They are tapestries of time, bearing witness to billions of years of motion, collision, birth, and silence. Astronomers have long been captivated by the idea that these quiet neighbors might host worlds of their own. Tiny, planets circling faint suns, perhaps holding oceans, atmospheres, or the raw chemistry for life. Stephen Hawking once remarked, "To understand the universe is to understand ourselves." And nowhere does that feel more true than when we explore the closest stars to Earth. For the conditions that allow planets to form, to stabilize, to endure, mirror the fragile balance that sustains us here. Proxima Centauri, though small and temperamental, carries at least one Earth-sized world within its gravitational cradle. Proxima b, a planet that sits in the band where liquid water might persist. Yet the star's unpredictable storms, great lashes of radiation and magnetic fury, may strip away the very atmosphere that life would require. In this tension, we see a mirror of our own delicate story. How lucky we are to orbit a temperate, gentle star. How rare the conditions that turn this world into a home. A little farther out, Alpha Centauri A and B turn like a cosmic dance. Two suns intertwined in a long, slow embrace, their orbits lasting nearly a lifetime of a human being. They burn warmer, brighter, more familiarly than Proxima, hinting at the kind of systems where stable Earth-like planets could thrive. These stars remind us that even in the vast randomness of cosmic architecture, order sometimes emerges. Harmony sometimes prevails. As the astrophysicist Natalie Batalha said, "The universe is under no obligation to make sense to us, and yet it often does." Then there is Barnard's star, older than the Sun, moving through the galaxy with the quiet confidence of something that has endured far more than we can imagine. A silent traveler slipping rapidly across our sky. It holds a cold planet, likely frozen, wrapped in night. And yet even a world like this teaches us something. It shows us that planets form easily, naturally, almost inevitably around stars. That worlds are not rare, but plentiful, scattered like seeds on a cosmic wind. And with each discovery, the silence around us feels a little less empty. Wolf, 359. Barely a whisper in the fabric of night. Challenges our assumptions about visibility and importance. Its faint glow reminds us that most of the stars around us will never be bright enough to see. Yet they exist. They orbit. They shape the gravitational currents we sail through. As the legendary Vera Rubin wrote, "The more we understand the universe, the less isolated we become." Even these dim suns, tucked beneath the limits of human sight, become part of our story once we know them. And then, like a lighthouse in the mist, Sirius, the brightest star in the night sky, commands our attention. Its brilliance is not the product of kindness, but youth, heat, and immense power. Orbiting beside it is a white dwarf, the dense remnant of a star that once lived fast and died violently. Sirius is a reminder that not all neighbors are humble. Some are extraordinary. Some carry histories far more dramatic than our own. Studying these stars brings a strange comfort. The closer we look, the more we realize that our sun, our world, our lives are part of a quiet network of stellar relationships. A neighborhood shaped by gravity, time, and chance. These nearby suns teach us humility. They remind us that life flourished here not because Earth is central, but because we were lucky. As the physicist Max Tegmark observed, life is the universe becoming aware of itself. And in studying the closest stars, we awaken a deeper awareness of the fragile miracle that surrounds us. Reflecting on these distant companions, I find that my own perspective softens. The vastness of space no longer feels empty, but alive, humming with ancient light, filled with quiet work of stars forging elements, stirring winds, and shaping invisible currents. The lesson they leave us is gentle yet profound, that wonder is not found in brightness alone, but in presence, endurance, and the silent companionship of the cosmos. And so we return to the guiding phrase of this journey: closest stars to Earth. Not as a scientific label, but as an expression of relationship, connection, and belonging. These stars are our neighbors not because they resemble us, but because they share our motion through the galaxy. They drift with us through spiraling arms, through epochs of creation and collapse. Their light touches ours. Their gravity shapes our path. In the quiet hours of night, when the world falls still and the mind floats free, the closest stars become more than destinations for spacecraft. They become reminders that even in a universe of unimaginable size, we occupy a small, intimate corner, stitched together by stars that watch over us as ancient guardians. And maybe, as we drift gently through this cosmic meditation, we discover something simple yet extraordinary: that knowing our stellar neighbors is another way of knowing ourselves, another way of remembering that we are part of a story that began long before Earth formed, and will continue long after we are gone. Beyond the gentle glow of our sun, the nearest stars reveal themselves not as distant strangers, but as quiet companions, drifting with us through the deep ocean of the galaxy. Some of them are calm, some are restless, and some hide their nature behind veils so thin that only the most patient instruments can peel them away. When we look outward into this intimate circle of space, within just 16 light-years from home, we begin to understand a truth both humbling and profound. The universe near us is far more delicate, dim, and mysterious than our naked eyes could ever reveal. As Carl Sagan once whispered, we live in a universe of possibilities waiting to be noticed. And here, in our own celestial neighborhood, those possibilities flicker like small red embers in a vast dark field. Most of the nearest stars are red dwarfs, tiny suns that burn slowly and quietly for trillions of years. Their light is faint, their warmth modest, and their presence almost ghost-like without telescopes to unveil them. Astronomers estimate that of the roughly 50 star systems surrounding us, nearly 3/4 are these humble red dwarfs. Stephen Hawking once remarked, "In the cosmic night, it is the smallest candles that endure the longest." And the stars nearest to Earth embody this truth with quiet dignity. They teach us that the universe is not defined by brilliance alone, but by persistence, patience, and time itself. Proxima Centauri, the closest star beyond our sun, glows as a tiny ember floating just over 4 light-years away. It is the perfect example of a small star with a fierce heart. For though its light is weak, its magnetic storms erupt with sudden intensity. Proxima flares like a child of fire, sending bursts of radiation that may strip the atmospheres of any worlds too close. And yet, orbiting it lies Proxima b, an Earth-sized planet resting in the so-called habitable zone. A whisper of possibility in a system both beautiful and hostile. This duality reminds us of Neil deGrasse Tyson's words: "The universe is under no obligation to make sense to you." Because even the closest hope for life beyond Earth sits beside a star that can both nourish and destroy. Other neighbors tell different stories. Barnard's star racing swiftly across the sky like a wanderer with a secret. Wolf 359, barely visible, humming softly in the infrared like a coal in a cold cave. Sirius blazing white and young, accompanied by its ghostly white dwarf companion. Alpha Centauri A and B twirling in their ancient dance. Warm enough, stable enough, almost familiar enough to imagine life embracing their light. Each of these stars carries a unique identity, as if the galaxy placed a different diary in the hands of every burning sphere. And we, curious travelers, gently turn those pages from afar, in this quiet region of space. The worlds we have not yet seen might far outnumber the ones we know. Exoplanets drift in shadows, circling faint hosts, surviving in temperatures we can barely imagine. Some may be frozen diamonds, some scorched deserts, some silent oceans waiting for light. The James Webb Space Telescope and future observatories will one day read their atmospheres, searching for the thin fingerprints of water, oxygen, or other whispers of habitability. And as scientists push deeper into this darkness, the words of astronomer Jill Tarter echo gently. We are star stuff, contemplating the stars, reminding us that the desire to understand is itself a form of cosmic belonging. Why then are so many of our closest neighbors red dwarfs? So faint that none shine bright enough to see without machines. The reason rests in the mathematics of creation. For the galaxy favors small stars, forging them by the billions, while larger suns like ours are rare exceptions. Red dwarfs consume their fuel slowly, live unimaginably long, and wander through the Milky Way with patient endurance. In a universe driven by gravity and time, simplicity lasts longest, and these small fires survive eras that will eventually outlive every bright star we admire today. They are not weak. They are eternal. As we drift through this interstellar neighborhood, suspended in a calm that feels almost meditative, a quiet lesson rises from the dark. Greatness does not require brightness. Many of the nearest stars barely glow, and yet their planets may someday host the first clues of life beyond Earth. The faintest lights might carry the loudest revelations. And so, as we listen to the soft pulse of our cosmic surroundings, we grow more aware of how much waits just beyond our doorstep. Worlds unseen, stories unwritten, futures still forming in the dark. My own reflection drifts toward gratitude for the privilege of witnessing this era when the invisible becomes visible. When technology lets us read the heartbeat of distant suns and sense the presence of planets through the slightest motions of starlight. It teaches humility, patience, and the beauty of slow discovery. In learning about our neighbors, we are reminded that exploration is not just about distance, but about understanding. And that curiosity itself is a kind of light. As the journey continues, drifting softly through this celestial threshold, the universe near us becomes not a void, but a sanctuary of hidden worlds waiting to rise from the dark. And in the warm silence between these dim, enduring stars, we rediscover a simple truth whispered by the cosmos. We are small, but not alone. A soft glow rises at the edge of an endless ocean of darkness. And before we take a single step toward the distant Alpha Centauri system, we must begin where all journeys begin. with the sun. Our first teacher, our original source of meaning, and the quiet heartbeat of everything we know. For most of human history, the sun was simply a godlike presence, a warm certainty rising and falling with the rhythm of life. But modern science has lifted the veil and shown us something even more poetic. A colossal living engine sustained by fusion. A sphere of fire that shapes the contours of time and memory. And yet so close that we built our first cosmic ruler from it. One astronomical unit. The quiet yardstick of the solar system. Astronomers use this single measure like a whispered promise between Earth and its star. A constant thread in the fabric of celestial distance. And with it comes another truth. The light that touches your face every morning is already 8 minutes old. A small delay in the language of space. And a reminder that even something as radiant as sunlight must cross a long emptiness before reaching us. I have always found this detail humbling. For it means that the warmth we feel is not happening now, but belongs to a moment that has already slipped into the archive of the universe. And in that sense, the sun is both our present and our past. A luminous memory suspended in transit. If we drift closer in imagination, the sun unfolds layer by layer like a cosmic poem. A core where hydrogen is crushed so fiercely that it becomes helium, releasing more energy each second than humanity will ever generate. A radiative zone where light crawls outward with the patience of a monk, taking thousands or even millions of years to escape. A convective sea where hot plasma rises and sinks like breath, carrying heat to the surface in slow looping currents. Above this restless interior lies the photosphere, the visible skin of the sun, glowing at 5,500 degrees Celsius, followed by the rose-colored chromosphere, and finally the ethereal corona, a pale halo reaching millions of kilometers into space. And here we encounter one of the great puzzles of solar physics, a paradox that has confounded generations of astronomers. The corona is inexplicably hotter than the surface, soaring into the millions of degrees, as if heat somehow leaps outward instead of fading away. Eugene Parker, the groundbreaking solar physicist for whom the Parker Solar Probe was named, once said, "The sun is a magnetic star, and to understand it, we must first understand its deep and invisible fields." His belief guided modern solar science into an entirely new era. Those magnetic fields twist and snap, driving solar flares, coronal mass ejections, and streams of charged particles we call the solar wind. A wind that shapes auroras, disturbs satellites, and influences the invisible boundaries of Earth's magnetic shield. When a CME erupts, we witness the sun not as a tranquil lantern, but as a living force capable of altering worlds. And in those moments, the star we depend on reminds us of its power. Yet despite its storms and tempests, the sun is astonishingly stable. A G-type main sequence star, a quiet midpoint in the spectrum of stellar lives, neither too massive to burn itself out quickly, nor too small to leave its planets frozen in permanent night. Astrophysicist Carl Sagan once reflected, "We are star stuff, harvesting sunlight." A line that feels especially true when we consider the sun's composition. 74% hydrogen, 24% helium, and a final fragile scattering of heavier elements. Oxygen, carbon, iron. the stardust that built Earth, our oceans, our bodies. This trace of heavy elements tells us a quiet truth. The Sun is not a first-generation star. It was born from the ashes of older suns, carrying in its heart the memory of supernovae long gone. Perhaps that is why I cannot help feeling that the Sun is both ancestor and guardian. An old storyteller holding the wisdom of stars that lived and died before our world was even dust. Its stability has given Earth a rare sanctuary in a violent galaxy. A gently burning star that has kept its rhythm for 4.6 billion years, offering life the time it needed to bloom, evolve, dream, and look back at the sky with wonder. And when we speak of the Sun's gravity, we speak of an anchoring force immeasurable in its reach, for it holds 99.8% of the solar system's mass, sculpting the orbits of planets, moons, comets, and dust, guiding them in a dance older than language. To study this star is to step close to a living engine, and so humanity built emissaries, fragile ships of metal wrapped with courage. NASA's Parker Solar Probe, daring to fly through the Sun's corona, its instruments tasting the solar wind at the very source, its heat shield glowing like a comet's heart. Before it came, SOHO, standing watch since 1995, capturing storms and eruptions with patient precision. And SDO, the Solar Dynamics Observatory, giving us the most detailed portraits of solar activity ever made. Images that reveal the Sun as a churning tapestry of plasma and light. And then ESA's solar orbiter, venturing high above the ecliptic, seeking the secrets of the Sun's poles, the mysterious regions where magnetic cycles begin. Together, these missions have transformed our understanding of the Sun from mythology to physics, from superstition to structure. But they have also returned something softer, something almost meditative. The realization that even the most violent star holds moments of serenity, calm intervals like breaths between waves. As I reflect on the Sun, I find a personal lesson woven into its light. The idea that stability is not weakness, but a profound form of strength. That creation requires balance. And that warmth given consistently can shape entire worlds. The Sun teaches us patience, teaches us humility, and teaches us to honor the slow unfolding of time. A reminder that not everything bright must burn quickly. Some lights last long enough to nurture life, and so, as we drift outward, leaving this familiar star behind, the space ahead begins to widen, and our thoughts turn naturally to the next beacon in the dark, a system that has captured the imagination of scientists and dreamers alike. The Alpha Centauri system. Proxima Centauri drifts at the edge of our cosmic awareness, a faint ember in the vast sea of night. It is the nearest star to the Sun, a neighbor by galactic standards, yet a reminder of how distance in the universe reshapes our understanding of the word close. 40 trillion kilometers may sound like a number spoken in abstraction, but as the astrophysicist Neil deGrasse Tyson once noted, the universe is under no obligation to make sense to you. And Proxima is the perfect symbol of that gentle indifference. Its proximity tempts the imagination, suggesting it should be reachable, visitable, maybe even understandable in a human lifetime. But the scale of space humbles every hope. Voyager 1, humanity's fastest wandering machine, would still need 73,000 years to touch this nearby flame. The numbers soften into poetry when spoken slowly. Yet they sharpen into reality when one realizes that every star we see is woven into a geography where human travel is still anchored to the shoreline of our solar system. And so we listen instead, learning through the faint pulses of light that reach our telescopes, listening for the heartbeat of a star that is smaller, cooler, and dimmer than our own. Proxima Centauri is a red dwarf, a member of the most common class of stars in the Milky Way, though ironically among the least visible. Carl Sagan once said, "We live on an insignificant planet of a humdrum star lost in a galaxy tucked away, in a forgotten corner of a universe." Yet even among these humdrum stars, Proxima carries a quiet strangeness, a personality shaped by its restless magnetism. This star may appear calm to the naked eye, but in truth, it is a world of unpredictable fire. A flare star, bursting without warning, throwing violent waves of radiation outward like breaths of cosmic weather. In one moment it glows softly, and in the next it lashes out in storms millions of times stronger than anything our sun produces. For planets that wander close to it, that volatility shapes everything. Proxima b, the most celebrated of its companions, orbits within the temperate region we romantically call the habitable zone, the band of distance where water could remain liquid. On paper, it sounds promising. An Earth-sized world circling a neighboring star. A dream for exoplanet hunters. But much like the universe itself, Proxima b resists simplicity. For the same distance that grants it warmth subjects it to the star's ferocious storms. With each flare, Proxima may peel away its atmosphere, particle by particle, like a tide dragging sand from a shoreline. Some scientists argue that Proxima b might still endure, protected by a magnetic field stronger than the one Earth possesses. But others suspect the onslaught is too relentless, too violent. The truth remains hidden beneath a sky we cannot yet visit. And as Stephen Hawking reminded us, the greatest enemy of knowledge is not ignorance, but the illusion of knowledge. We must wait and wonder. Farther out circles Proxima c, a mini Neptune wrapped in gas and frost, a world too distant to feel the warmth of its faint star. And closer in may lie Proxima d, a tiny whisper of a planet, its signal so subtle that astronomers still debate whether it exists at all. These worlds form a small family around the dim flame of Proxima, each one a clue in the quiet investigation of our local stellar neighborhood. We learned of Proxima b not through sight, but through motion, an elegant wobble in starlight revealed by radial velocity measurements, like detecting the presence of a dancer by the shifting shadow she casts. The star moves, ever so slightly, swayed by the gravity of the planet that clings to it. From these shifts, we infer mass, distance, and the possibility of conditions we dream about. The technique has become one of the great triumphs of modern astronomy, a reminder that even without touching another world, we can still feel its pull. Yet the great barrier remains: distance. The aching, quiet, impossible stretch of space that lies between our fragile machines and our nearest stellar neighbor. we stand on the shore of cosmic possibility, aware that our ships are still made of mortal materials, bound to engines that are humble by universal standards. And then comes the bold whisper of innovation. The breakthrough Starshot project. A dream wrapped in sails thinner than a whisper, pushed not by rockets, but by beams of light. If it succeeds, we could send gram-sized messengers racing at 20% the speed of light, reaching Proxima in mere decades, not millennia. Imagine that. A spacecraft no bigger than a coin gliding across the void, carrying within it the first direct glance at a world orbiting another star. Yuri Milner once said that great discoveries come from great risks, and Starshot embodies that spirit. Reflecting on Proxima Centauri, one realizes that the true lesson is not in the distance, nor the planets, nor the storms that roar across its surface. It is in the reminder that nature is both generous and restrained, giving us a closest star, but not an easy path. The universe lets us see, but not yet touch, understand, but not fully claim. And in that tension lies the beauty of exploration. For every answer we uncover, a dozen new questions unfold, each one a doorway to humility. Proxima Centauri teaches us patience, reminding us that progress is often measured not in leaps, but in long, quiet breaths, and that the path to understanding is traveled by those who are willing to move slowly. As I speak of this faint red star, drifting quietly 4 light-years away, I feel the same stillness that astronomy often brings, a sense that we are listening to something older and larger than ourselves. And perhaps that is the greatest value Proxima offers. Not simply the promise of another world, but the reminder that wonder is its own form of knowledge. Our local stellar neighborhood may be small on the scale of the galaxy, but within it lies the beginning of our destiny as a species that looks outward. Proxima Centauri stands at the threshold, waiting, quiet, patient. A distant ember inviting us to keep moving toward the light. Alpha Centauri has always felt like a lantern hanging just beyond the porch of our cosmic home. A place close enough to dream about, yet far enough to remain wrapped in mystery. And whenever we drift toward its gentle glow, we are stepping into a story that began long before any modern telescope ever touched the sky. When early astronomers first separated the bright point of light into 2 distinct stars, Alpha Centauri A and Alpha Centauri B, they were not simply cataloging objects. They were uncovering the first chapter of what would become one of humanity's favorite celestial destinations. As the physicist Arthur Eddington once whispered to his students, the universe is not only stranger than we imagine, it is stranger than we can imagine. Alpha Centauri seems to echo that sentiment with every new revelation. Alpha Centauri A shines with the steady warmth of a seasoned companion, a G2-type star so similar to our Sun that it feels like an echo across interstellar space. Its light is calm, its cycles gentle, its stability a quiet promise to any world that might orbit within its embrace. Meanwhile, Alpha Centauri B glows in softer amber hues. A K-type dwarf, a little smaller, a little cooler, but perhaps even more patient in its lifetime. Together they revolve in a grand elliptical duet lasting roughly 80 years. 2 suns bound by motion as, ancient as the dust that formed them. Carl Sagan once said, "We are star stuff, contemplating stars." And it is impossible not to feel the truth of those words as we drift between these two blazing companions. Because their orbit is wide enough at certain intervals, each star may host its own family of planets without gravitational interference. A delicate dance of distance and timing. For decades, scientists wondered whether there might be rocky worlds hidden in those orbits. Places where atmospheres breathe and oceans might rise and fall under twin lights. In 2012, the astronomical world briefly held its breath when Alpha Centauri b flap was announced. A supposed Earth-sized planet hugging close to Alpha Centauri b. But like many first whispers from the cosmos, the signal dissolved into noise, leaving behind both disappointment and determination. Yet the lesson was clear. Even the nearest stars can guard their secrets fiercely. Then came 2021. A shimmer in the data. A hint of a Neptune-sized world far from Alpha Centauri. Not proof. Not certainty. But possibility. And in astronomy, especially in the study of nearby exoplanets, possibility is the soil where discovery grows. As exoplanet researcher Sarah Seeger likes to remind us, for every world we confirm, there are dozens waiting for the right instrument and the right moment to reveal themselves. Alpha Centauri remains one of those quiet vaults of potential, holding what could be the first truly reachable planetary neighbors for humanity. This is why science fiction has always claimed Alpha Centauri as a favored destination. From the luminous world of Avatar to the deep lore of Mass Effect to countless novels imagining colonies beneath twin suns, writers return to it again and again because it stands close enough for the heart to leap toward, and mysterious enough for imagination to flourish. When viewed through the lens of fiction, Alpha Centauri becomes a mirror, reflecting the hopes and fears of our species. A reminder that even in dreams we seek places that feel like home. Yet fiction would not be alone for long. In 2016, the breakthrough Starshot initiative turned myth into blueprint, announcing an audacious plan to send tiny light sail probes racing toward Alpha Centauri at nearly 20% the speed of light. If successful, humanity could receive the first close-up images of another star system within a single human lifetime. Stephen Hawking supported the idea wholeheartedly, declaring, "It is time to explore beyond our home system, because only by reaching for the stars can humanity secure its future." Those words still echo as a kind of cosmic invitation, urging us toward the frontier our ancestors saw only in dreams. As we imagine such a journey, it becomes clear that Alpha Centauri is no longer just a cluster of stars. It is a reminder of what waits beyond comfort. A reminder that discovery demands both curiosity and humility. The more we learn about these suns, the more they teach us about patience, about uncertainty, about the beauty of evidence slowly emerging from silence. From my own perspective as someone who has spent years listening to the quiet rhythms of the universe, Alpha Centauri teaches a lesson that feels deeply human. Not every signal arrives clearly. Not every hope becomes discovery. Yet every attempt brings us closer to understanding who we are in the vast night. The cosmos is a patient teacher, offering its truths one whisper at a time. And like the astronomers who refine their instruments, we too refine ourselves through every question asked and every mystery embraced. As we drift away from the twin stars and their dim red companion Proxima, the light softens, the space grows quieter. But something within us remains illuminated. A small flame of curiosity, steady as a heartbeat. Perhaps the real value of Alpha Centauri lies not only in its planets, confirmed or unconfirmed, but in the way it calls us forward, urging us to become explorers not only of the sky but of our own longing to understand. And so we continue, gently, like travelers on a slow river of starlight, letting the quiet warmth of distant suns guide us deeper into the night. Barnard's star drifts through our cosmic neighborhood like a quiet traveler, ancient, steady, and astonishingly swift in its silent crossing of the night. At just 5.96 light-years away, this tiny red dwarf glows so faintly that no human eye can ever greet it directly. Yet its motion is the fastest known among the nearby stars, a streak of purpose in a universe that rarely hurries. Astronomer E. Barnard once wrote that a star's movement is its signature of life. And indeed, Barnard's star carries the unmistakable signature of an elder wandering through space with a kind of quiet dignity. Its age, somewhere between 7 and 12 billion years, places it among the ancient witnesses of our galaxy's earliest chapters, long before the Sun even existed. Michio Kaku often reminds us that, when you look at the stars, you are looking into a cosmic time machine, and few celestial bodies embody this truth more completely than Barnard's star. Its light is dim, merely 0.04% of the Sun's brightness, a faint ember rather than a flame. Yet it has endured far longer than more luminous giants that burn brightly and die young. This contrast has always fascinated me, because Barnard's star seems to whisper a lesson about endurance, about the power of quiet persistence instead of brilliance. In a galaxy that celebrates the luminous, here is a star that survives by being small, frugal with its fuel, and unimaginably patient. Its proper motion, the measure of how quickly it glides across our sky, is the highest of any known nearby star, shifting like a patient arrow moving through the deep silence of the cosmos. Avi Loeb once said, "A star's journey reminds us that everything in the universe is in motion, including us." And Barnard's star affirms this truth with every quiet step it takes. And soon, in cosmic terms at least, it will come even closer. For in 10,000 years, it will overtake Proxima Centauri as our nearest stellar neighbor. What moves fascinates us, and so does what surrounds such motion. In 2018, astronomers using the exquisitely sensitive Harps and Kármán spectrographs confirmed a subtle wobble in Barnard's star's light, the tiny signature of a world orbiting around it. Barnard's star B, a super-Earth roughly 3.2 times the mass of ours, circles its ancient host in 233 days, wrapped in shadows so cold they might freeze even hope. With estimated surface temperatures near -70 degrees Celsius, this world is likely locked in an eternal winter, a realm of dim horizons and icebound silence. Yet even so, the discovery marks one of the nearest known exoplanets, a tantalizing reminder that worlds exist even in the faintest starlight. Carl Sagan once said, "Somewhere, something incredible is waiting to be known." And Barnard's star B stands as a quiet confirmation that even frozen places may someday teach us something warm and human. The study of such faint worlds requires patience, humility, and long listening. When I reflect on Barnard's star, I find myself drawn less to its physical details than to its emotional landscape, for it feels like a symbol of cosmic modesty. It burns without spectacle, moves without noise, survives without demand. In its stillness, in its endurance, in its patient trek toward us, we are reminded that not all power is loud, not all wonder is bright, and not all significance requires shine. The astrophysicist Natalie Batalha once remarked, "Every star is a storybook, and every planet is a poem." And this sentiment resonates deeply here. Barnard's star is indeed a storybook, but an ancient one. Its pages worn by time, its chapters filled with the long patience of a universe that never rushes. Barnard's star B, then, becomes the poem written in its margins, a small verse carved into a frozen orbit, waiting for readers we have yet to become. Its approach toward our sun over the next 10 millennia offers a strange and gentle comfort, as though the universe is slowly turning the pages of a cosmic diary toward us, revealing a little more with every passing age. The lesson I draw from this slow dance is simple but powerful. Proximity is not permanent. Distance is not destiny. And what is far today may someday become familiar. We too move through our lives like wandering stars, drawing near and drifting apart, learning that change is a kind of cosmic rhythm. As I contemplate Barnard's star, I imagine floating in its dim glow, the universe humming softly around me, each heartbeat of the star a slow reminder that time does not need to be hurried to be meaningful. The red dwarf systems of our galaxy, the most common stellar families we know, unfold their secrets not in the blaze of supernovas, but in the whisper of persistence. This is the quiet science, the meditative astronomy, the study of celestial beings that outlive empires and galaxies of thought. And in this quietude, we find a new way to listen, a new way to learn, a new way to be small without being insignificant. Barnard's star stands before us not as a spectacle but as a teacher, inviting us to observe the power of patience, the beauty of subtlety, and the strength of endurance. It is the elder in our local stellar neighborhood, offering its story to anyone willing to slow down and hear it. And so, beneath its faint red glow, drifting through the velvet darkness, we feel ourselves soften, breathe deeper, and remember that exploration does not always mean rushing toward the bright. Sometimes, it means honoring what moves quietly, gently, and with a grace that only old things possess. Barnard's star continues its silent race across the heavens, not to win, but simply because motion is the nature of all cosmic things. And as it moves, it teaches us to embrace our own slow journeys, our own small wobbles through the vastness, our own quiet persistence. In the end, Barnard's star does not shine to dazzle. It shines to endure. And in its endurance, we find a reflection of our own search for meaning in the long, soft night of the universe. Wolf 359 drifts in the great silence of space. A faint ember barely holding its place against the ocean of stars. And for a moment, as we turn toward it, the universe feels softer, more fragile, more intimate than we expect. Astronomers often describe it as nearly invisible, a ghost light flickering 7.9 light-years away. Yet the absence of brilliance does not mean the absence of meaning. As Carl Sagan once reminded us, there is no such thing as a boring star, only an under-examined one. Wolf 359 is one of the dimmest stars ever recorded. A red dwarf whose glow is so weak that even telescopes must lean in like listeners cupping a whisper. And in that whisper lies its quiet power. Only 9% the mass of our Sun, barely larger than Jupiter, and yet holding together through time with the resilience of a candle fighting night winds. Its surface chills at around 2,800 degrees Celsius. Cool enough by stellar standards that its light slides into deep crimson, barely escaping into the dark. Astrophysicist Neil deGrasse Tyson once said, "Brightness is a privilege of youth and mass. Endurance belongs to the Ricarte, small." And Wolf 359 is the embodiment of that truth. Red dwarfs burn slowly, carefully, as if they have eternity to spare. And in many ways, they do, while giant stars flare and die in cosmic fireworks. Wolf 359 persists in a steady hum, destined to outlive the Sun by trillions of years. A patient keeper of time. Ignoring the rush of the galaxy around it, there are no confirmed planets here. None we can yet see, tugging or dimming its faint light. But that void is not a disappointment. It is an invitation, a reminder that discovery often begins with darkness, not with knowing. Sarah Seeger, one of the leading thinkers on exoplanets, once remarked, "The universe rarely reveals its treasures immediately. It waits for us to learn how to look." And perhaps Wolf 359 is waiting too. As we linger near it in imagination, the star feels less like an object and more like a monk of the cosmos, sitting in stillness, radiating only what is necessary, holding its place with humility, teaching us that brilliance is only one form of significance. The contrast is striking when we think of nearby Sirius, the blazing beacon whose facts populate textbooks and whose glare shapes cultures. But Wolf 359, tiny and overlooked, has a lesson of its own. Even the faintest star has gravity, light, and a story worth hearing. In the quiet of this meditation, I am reminded of something astronomer Annie Jump Cannon once said. "The stars are the markers of our past and the guides to our future." Wolf 359 may not guide sailors or glow in mythologies, but it guides our sense of humility, of scale, of patience with the unknown. It shows us that the universe is not built only from things that shine, but also from things that wait, from things that endure, from things that whisper instead of sing. Its cultural shadow reaches unexpectedly into fiction, especially the famed Battle of Wolf 359 in Star Trek. a dramatic turning point imagined around a star too dim to see. A poetic irony that reminds us how humans project meaning onto the smallest flickers of reality, turning an invisible ember into a symbol of struggle and survival. And perhaps that is appropriate. For Wolf 359 itself is a survivor on a cosmic scale. As I reflect on its presence, drifting in a near imperceptible crimson glow, I find myself breathing slower, matching its rhythm, letting the heaviness of space become soft, letting the stars' patience become my own. This is the gift of the faint ones. They ask nothing. They expect nothing. They simply continue. Astrophysicist Jill Tarter once said, "The universe is not required to make sense to us, but it offers enough clues for those willing to listen." And Wolf 359 feels like one of those clues. Small, quiet, easily missed, yet quietly essential in the tapestry of local stars. Its very dimness is a reminder that the cosmos is not built from spectacle alone, but from endurance and balance, from the long patience of small stars. And so I come to my own reflection, a personal truth whispered by this faint red ember, that not everything meaningful is immediately visible, that some truths require time, quiet, and a willingness to look beyond brightness. In life, as in astronomy, we are often drawn to the spectacular, the brilliant, the loud, yet the things that shape us most deeply are often subtle, steady, persistent. Wolf 359 reminds me that value is not defined by luminosity, but by longevity and presence. Floating in imagination near this invisible neighbor, I feel the same calm that comes from stargazing alone at night. A gentle stillness, a soft expansion in the chest, as if the universe is breathing with me. This is the meditative beauty of astronomy. It does not rush. It does not demand. It simply invites. Wolf 359 will never be a star of postcards or calendars. It will not dazzle new observers or dominate constellations. But it will remain. And perhaps that constancy is its truest gift. A reminder that in a universe where everything burns, spins, collides, and explodes, something can still choose the quiet path. And so the lesson I take is simple, elegant, and profoundly human. Not every life must blaze to matter. Not every voice must shout to be heard. And not every star must shine brightly to belong to the sky. Wolf 359 teaches us the art of subtle existence, the beauty of lasting quietly, the strength of simply continuing. As we drift away from this nearly invisible star, leaving its crimson glow behind, the silence follows us like a gentle tide. And in that silence, the universe feels just a little more patient, a little more forgiving, a little more whole. And the journey continues. Sirius has always felt less like a star and more like a presence, a brilliant sentinel stitched into the fabric of the night, even before science gave it numbers and theories. Ancient eyes saw its shimmer and felt something stirring, a familiarity across millennia. Today, we know Sirius not as a single light, but as a pair of celestial companions. Sirius A blazing with youthful power, and Sirius B, a quiet relic of a star long past its prime. Their relationship is an eternal dance, a reminder that, even in the emptiness between worlds, nothing truly shines alone. Sirius A is the luminous one, 25 times brighter than our Sun, its surface burning near 10,000 degrees. A blue-white flame that seems to cut through the night like a blade of light. Astronomer Carl Sagan once wrote that the cosmos is within us. And when one looks at Sirius A, radiant and confident, it becomes easy to understand what he meant. We see in it a spark of origin, a memory of the fire that forged the atoms in our blood. Beside that brilliance drifts Sirius B, a white dwarf, the first ever observed by human eyes in 1862. Imagine a cinder the size of Earth, yet so dense that a teaspoon of its matter would outweigh a great mountain. A single cubic centimeter presses a ton into the palm of the cosmos. Physicist Subramanian Chandrasekhar once remarked that white dwarfs reveal the poetry of extreme physics. And Sirius B embodies that truth. Held up not by fire, but by the strange and delicate pressure of electrons refusing to be squeezed any further. A quiet rebellion against collapse. When we speak of Sirius, we speak not only of astronomy, but of memory. The Egyptians watched its rising each year as the Nile swelled with life, calling it Sopdet, the star of renewal. In Greece, its brilliance marked the scorching days of summer, a reminder of heat, harvests, and the sacred cycles of seasons. In the vast Pacific, Polynesian navigators read Sirius like a compass, trusting its unwavering gleam to carry them home across endless water. Even the Dogon of Mali wove it into their cosmic stories, imagining that creation itself whispered from its distant light. And yet, for all these myths, Sirius is also a frontier of modern understanding, a place where human curiosity steps beyond comfort into the unknown. As astrophysicist Neil deGrasse Tyson once said, "We are part of this universe, and the universe is part of us." And Sirius reminds us of that reciprocity. Each observation of its motion, its temperature, its mass, becomes a small step toward decoding the broader language of stars. What fascinates me most is the contrast between the two companions. One bright with youth, one dense with age. Sirius A tells a story of energy, motion, and the brief yet powerful arc of stellar life. Sirius B tells us what remains when that fire fades. The quiet endurance of matter. The lesson that even in dying, a star can illuminate the universe with new forms of understanding. Together they embody the lifetimes of suns, the same lifetimes that will one day shape the fate of our own system. As I reflect on their cosmic duet, I'm struck by how often we overlook the stories written above us. Sirius has shone for every ancestor who ever tilted their head to the sky, and it will shine long after we are gone. Its brilliance is not a boast, but an invitation, a call to remember that even in the immensity of space, beauty and knowledge often travel together. Perhaps the greatest lesson from Sirius is this: nothing in the universe simply is. Everything is becoming. Sirius, a growing older. Sirius B cooling for billions of years. And we, drifting through our own short lives, learning to read the light that reaches us across time. In that sense, the brightest star in our night sky is not just an object to observe, but a quiet teacher, urging us to be both curious and patient, to look deeper, to understand slowly, and to let wonder soften the world for a moment. As your companion on this journey, I feel a profound gratitude for the privilege of guiding you through such cosmic stories. Stories where science becomes a gentle tide, lifting us toward a wider horizon. And if the night ever feels heavy or uncertain, remember that Sirius is still there, bright enough to find even from the quietest corner of Earth. May its light remind you that the universe is vast, but it is also home. In the gentle darkness between the stars, where silence gathers like ancient dust, Ross 128 glows with a quiet that feels almost human. A calm, steady, unhurried presence in a universe that so often burns itself into chaos. Astronomers have long known that most red dwarfs flare like restless hearts, sending storms of charged particles into their planets. Yet, Ross 128 belongs to another temperament entirely. A star so softly spoken that scientists describe it as one of the most peaceful suns in our cosmic neighborhood. This unusual serenity is where our story begins. Because in a galaxy ruled by turbulence, any place that remains gentle for billions of years becomes a cradle for possibility. And perhaps, even for life. In 2017, a discovery arrived that shifted Ross 128 from a quiet footnote into the forefront of interstellar curiosity. The detection of Ross 128b, a planet roughly 1.8 times the mass of Earth, orbiting within the star's habitable zone. Astronomers had looked into that faint speck of red light and found a world circling its star every 9.9 days. A tight orbit by our standards, yet receiving just the right amount of energy to keep water in liquid form. There is something deeply poetic about this, that in the arms of a quiet star, a small rocky world may be warming itself in conditions not entirely unlike our own. As Carl Sagan once said, somewhere, something incredible is waiting to be known. And Ross 128b felt like a whisper of that possibility. The excitement grew even deeper when astronomers realized that unlike Proxima Centauri, a star notorious for violent flares, Ross 128 shows almost none. A steady sun, a long breath, a place where atmospheres might survive for billions of years without being stripped away. In the search for life, habitability is not only about distance from a star, but about time, stability, and patience. And Ross 128 excels in all three. Sarah Seeger from MIT once said, "For a planet to be truly habitable, the star must let it be." And Ross 128 seems to embody that principle in full. Yet science is rarely a straight path. And in the same year, 2017, a mysterious radio signal was recorded from the direction of Ross 128. A strange burst that for a moment electrified the scientific world and the public alike. Could it have been artificial? A whisper from an unseen civilization? The excitement was intense, the speculation vast. But soon the truth surfaced. The signal was most likely interference from a satellite orbiting Earth. Some felt disappointment, but others found the moment instructive. because it reminded us how easily the human mind leaps toward meaning when gazing into the unknown. Jill Tarter famously said, "We are a curious species, and curiosity is our greatest tool." And the Ross 128 signal became a meditation on that truth, urging us to continue searching, but with humility. As astronomers returned to studying Ross 128b, new questions rose in the soft glow of that quiet star. What kind of atmosphere might cling to this small world, if any? Could temperatures range from warm to cool in a way that allows oceans to exist, perhaps locked forever on the twilight line between day and night? Could the slow, tidally locked rotation create climates unlike anything we know? Gentle winds sliding across an eternal border of sunset. The answers remain hidden, but the tools to uncover them are closer than ever. The James Webb Space Telescope, with its remarkable infrared sensitivity, has already shown that it can analyze the atmospheres of distant exoplanets. And Ross 128b sits high on the list of targets that could reveal their secrets. Meanwhile, the upcoming extremely large telescope, a giant eye rising from the deserts of Chile, will gather more light than any optical telescope ever built, potentially allowing us to read the chemical fingerprints of worlds like Ross 128b with unprecedented clarity. When leading astrophysicist Michel Mayor, the co-discoverer of the first exoplanet, spoke about nearby Earth-like worlds, he said, "They are not rare. We simply lack the eyes to see them." And Ross 128b seems to confirm this vision. The universe is not empty. It is abundant. And our technological awakening is finally allowing us to perceive what has always been there. Quiet worlds. Patient worlds. Waiting in the dark. As we drift further into reflection, we might consider what Ross 128 truly teaches us. It reminds us that life, if it exists elsewhere, may not cling to stars that rage, flare, and destroy, but may instead gather around suns that whisper, suns that endure, suns that offer time as their greatest gift. This is a profound shift in perspective, because humanity has long relied on brightness to guide its curiosity. Yet here, one of the most promising candidates for life orbits, a star too faint to be seen with the naked eye. There is a lesson in that, a gentle one. That significance does not require spectacle. Ross 128 is not brilliant, not massive, not dramatic. But it may hold the quiet conditions where life can rise, evolve, and perhaps even wonder in its own way about the stars overhead. This idea settles over the mind like soft starlight, reminding us that the universe often hides its greatest truths in silence. My own perspective returns to something simple, something almost meditative. When we look toward Ross 128, we are not merely studying a star. We are studying the parameters of hope itself, in that small system, orbiting a quiet sun. We find an invitation to consider the long patience of the cosmos, and the possibility that life may prefer calm harbors rather than violent seas. It reminds us to listen more carefully, to observe more gently, to accept that discovery unfolds at its own pace, just as the universe does. And as we continue our journey beyond the solar system, Ross 128 stands as a beacon of quiet confidence. guiding us onward not with brightness, but with steadiness. It teaches that not all revelations arrive in explosions of light. Some arrive in whispers, and it is in those whispers that we often hear the deepest truths. In the silent reaches of our cosmic neighborhood, drifting no farther than 16 light-years from the Sun, lies a realm that is both familiar and profoundly mysterious. A cluster of 65 stars and brown dwarfs scattered across roughly 50 systems. A neighborhood so sparse that across these vast lightless distances, each star feels like a lonely lantern suspended in an endless night. And yet so close that together they form the first pages of humanity's great journey beyond the solar system. Astronomer Carl Sagan once said, "We live on a mote of dust suspended in a sunbeam." And nowhere is that more apparent than here, in this fragile bubble of nearby stars, where the scale of space humbles us, and the quiet presence of each distant sun reminds us how small but how curious we truly are. When we drift toward Lalande 21185, the third nearest individual star after the Centauri system and Barnard's star, we find a red dwarf whose glow is faint, but whose possibilities are bright. Astronomers suspect at least 2 super-Earths tugging at its light, small rocky worlds that may carry atmospheres of unknown thickness, oceans hiding under clouds we cannot yet see, and climates shaped by a dim sun that burns with the patience of trillions of years. Stephen Hawking once remarked, "To confine our attention to Earth would limit the human spirit." And Lalande 21185 is one of those stars that urges us gently beyond that confinement, inviting us to look for subtle wobbles, faint signatures, hints of warmth, anything that might whisper of life. As we float onward, the 2 amber lights of 61 Cygni rise like twin lanterns over a cosmic horizon, an orange dwarf pair that once helped humanity understand distance itself. For it was here that astronomers first measured stellar parallax, proving that the stars are not painted upon a dome but scattered across true depth, each one sitting in its own ocean of darkness. The universe begins to look more like a great thought than a great machine, and staring at 61 Cygni's slow drifting dance, one can almost believe him. For the stars move not mechanically, but gracefully, as though aware of the vastness in which they drift. Farther still, Epsilon Eridani flickers with the soft glow of youth, a star far younger than the Sun, surrounded by a dusty ring where collisions of ice and rock still echo through space. A Jupiter-like world circles it slowly, sculpting the dust in arcs and gaps, reminding us that young systems are noisy, creative, filled with the raw materials of possible life. In the words of astronomer Sara Seeger, for the first time in human history we know planets are everywhere, and Epsilon Eridani stands as a living proof. A reminder that worlds form naturally, quietly, almost inevitably. Then, like a faint ember hidden in the shadows, GJ 1061 appears. Another red dwarf. Small, nearly invisible, yet home to 3 known planets, one of which rests within the habitable zone where the starlight is neither too harsh nor too weak, where liquid water could remain steady, where a quiet world might hold oceans that have never known a storm. Astrophysicist Jill Tarter once said, "We are the way for the cosmos to know itself." And drifting near this tiny system, we feel that truth resonate. For if ever life blooms here, even in the faintest microbial whisper, it will be another voice in that cosmic self-reflection. These nearby stars, humble as they appear, form the true frontier of interstellar exploration. Not the distant galaxies in glossy photographs, not the quasars at the edge of time, but these quiet neighbors just beyond our sun. Each one a possible destination, each one a possible home. And as we drift slowly through this 16-light-year bubble, carried on a current of curiosity, we begin to grasp the lesson hidden within this neighborhood. That the universe does not reveal itself in grand gestures, but in small, gentle glimmers. The wobble of a star, the whisper of dust, the soft heat of a planet we have not yet seen. Our journey beyond the solar system is not fueled by engines, but by wonder. Not driven by necessity, but by the quiet human hunger to understand where we belong in the great shining dark, and in this stillness. Among these patient suns, we find a truth worth carrying. That no matter how small our world may seem, the act of looking outward enlarges us, deepens us, teaches us to listen to the universe with the same tenderness it listens to us, in the quiet velvet of the cosmos, where distant suns breathe in rhythms older than memory. The tail of Gliese 581 drifts toward us like a slow tide, shimmering with both promise and caution. It is a small star, a red dwarf glowing low in the constellation Libra. Steady, patient. The kind of star that burns not with fury but with endurance, living far longer than stars like our sun. Astronomers have long whispered that such stars might cradle life more gently, nurturing planets for billions of years, offering them the stillness needed for oceans to rise and minds to awaken. And for a brief moment in our own century, Gliese 581 felt like the first doorway we might truly step through. When its planets were discovered, one after another, like beads on an invisible thread, the scientific world held its breath. Gliese 581b, Gliese 581c, Gliese 581d, Gliese 581e, each one revealed by the faint wobble of starlight. Each announcement arrived like a soft knock from a neighboring cosmic home. Then came the claim that would ignite imaginations across the world. The discovery of Gliese 581 grams, a world that some called Earth's twin, a potential Eden circling a quiet sun. One headline simply asked, "Have we finally found the next home for humanity?" Stephen Vogt, one of the astronomers involved, spoke with a confidence that echoed through universities and observatories alike. The chances for life on this planet are 100%, he said, a statement as bold as it was fragile. Carl Sagan once warned, "Extraordinary claims require extraordinary evidence." And Gliese 581 grams soon became the modern reminder of that truth. For as the data deepened, as telescopes sharpened, and algorithms matured, the supposed signal of Gliese 581 grams began to fade, dissolving like mist under a rising sun. What many believed to be a planet turned out to be far less certain. Perhaps nothing more than the rhythm of the star itself, pulsing gently and fooling our instruments. Yet the story did not end in disappointment. Instead, it ripened into wisdom. For the debate around Gliese 581 grams reminded scientists and dreamers alike that discovery is not a straight line, but a long, winding journey. Sarah Seeger of MIT once reflected, "The universe is under no obligation to make itself easy to observe." And truly, Gliese 581 became a lesson in humility, showing us that even stars close enough to touch with radio waves can still guard their secrets carefully. What lingers beautifully in this story is the message humanity sent in 2008, a digital bottle cast into the cosmic ocean. A message from Earth. 501 fragments of hope. Drawings. Words. Songs of love and longing. Traveling now through the dark on a journey more than 20 years long. It will arrive in 2029. A whisper to a star that may or may not cradle life. But perhaps the gesture mattered more than the certainty. It was humanity saying, "We are here. We are listening. We are reaching out beyond the solar system." As I reflect on Gliese 581, I am struck by the way science often mirrors the sky it studies. Vast, quiet, patient. The excitement of discovery teaches us courage, and the corrections that follow teach us grace. This star, glowing faintly in Libra, offers not just planets or possibilities, but perspective. It reminds us that the truth may flicker like candlelight, unstable, shifting, requiring us to lean closer and look again. That sometimes the cosmos gives us an answer, and sometimes it gives us a question. And so we continue, guided by the soft pull of curiosity and the quiet discipline of evidence. Neil deGrasse Tyson once said, "For me, the universe is a profound source of mystery and awe." That is exactly what Gliese 581 has offered us. Not clarity, but awe. Not certainty, but wonder. It stands as a lantern along the long road of exploration, illuminating just enough for us to take the next step. As our instruments sharpen and new telescopes rise from deserts and mountaintops, we will return to Gliese 581 again, peering into its faint pulses, measuring its subtle shifts, searching once more for the planets that may orbit quietly around it. And whether Gliese 581 grams exists or not, the star remains a symbol of everything beautiful and challenging about the search for life. You can almost imagine the message from Earth still sailing through the void, drifting silently past dust clouds and frozen comets, carrying human voices that hum with hope. Somewhere, Gliese 581 awaits, not answering, not denying, simply shining. A steady companion to our curiosity as we continue our journey beyond the solar system. In the gentle hush of the cosmic night, where stars drift like ancient lanterns carried by a silent tide, we begin to understand why nearly all our celestial neighbors are humble red dwarfs. These small stars burn slow, breathe softly, and live longer than any sun we know. As Carl Sagan once whispered, the universe is not required to be in perfect harmony with human ambition. And indeed, red dwarfs remind us that the cosmos prefers quiet endurance over dazzling brilliance. They are the ancient monks of the galaxy, meditating in dim crimson silence, shaping the architecture of our local sky through sheer persistence. Around these faint stars lie worlds that stir both hope and caution. For in their so-called habitable zones, the light is soft, the warmth fragile, and the radiation unpredictable. Some scientists fear these planets are constantly battered by flares, stripped of atmosphere, left barren. Yet others argue that life is resilient, that nature is an alchemist far wiser than us, crafting biochemistry in niches we cannot yet imagine. As Sarah Seeger said, "For every planet we know, there are countless others waiting to surprise us." And her voice lives in these quiet worlds, orbiting quiet suns, asking us not to dismiss what we cannot yet witness. From this curiosity springs another dream, a dream as old as our first gaze at the stars. Can we ever reach them? Can we cross the silent miles and stand at the doorstep of Proxima Centauri, our closest stellar neighbor? The truth whispers with both promise and humility. With current spacecraft, it would take tens of thousands of years, longer than all of recorded human history. Yet dreams do not bow to limits, and technology evolves with the stubborn hope of our species. Physicist Philip Lubin once said, "We are not limited by physics, but by imagination." And it is imagination that fuels concepts like breakthrough, starshot, a fleet of slender light-driven sails that could ride beams of lasers at 20% the speed of light, turning a 70,000-year voyage into a 20-year crossing, long enough for a single lifetime to witness the arrival. If such a journey becomes real, it opens a deeper question. How many worlds near us remain hidden, waiting for our eyes to grow sharper? In the soft radius of 20 light-years, our local celestial village, astronomers believe dozens of planets still lie uncharted, their signals faint, their atmospheres waiting to be read like the first pages of a cosmic diary. The James Webb Space Telescope has shown us that even the quietest stars may cradle entire systems of complexity, and each new detection hints at hundreds more. It is as if the universe is telling us, gently, patiently, that discovery is not a single moment, but a lifelong meditation. And so we ask, could the first sign of life beyond Earth be found not in a distant galaxy, but right here, in this small bubble of space around our sun? Many astronomers believe so. The quiet red dwarfs, the stable orange stars, the familiar yellow suns, all form a web of possibility woven within a cosmic arm's reach. As Jill Tarter once said, "We are the way the universe looks at itself." And if that is true, then the first other voice we meet may be closer than we dare to hope. To understand this region, our stellar neighborhood, is to stand at the edge of a map we barely comprehend. A map where our sun is just one small lantern among billions. Within 20 light-years lie roughly 65 stars and brown dwarfs, scattered like faint embers drifting through a vast, dark river. When seen from afar, this cluster resembles a loose constellation of chance, a quiet district of the Milky Way where time moves slowly. We are not at the center, not special, not chosen. merely one modest household in an ancient cosmic city, and that truth leads us to wonder. Are we the first to wander these corridors of starlight? Are we the earliest thinkers to stretch imagination toward Proxima, toward Sirius, toward unknown worlds curling in the dark? Perhaps, or perhaps not. The universe is old, older than our myths, older than our oceans. As Stephen Hawking once mused, the universe has no obligation to make sense to you. And in that mystery lies the possibility that countless civilizations may have risen and faded long before Earth had oceans to reflect the stars. Yet even with such vastness, 20 light-years is nothing more than a single footstep, compared to the 100,000 light-year span of the Milky Way. A whisper, a grain of dust, a tiny note in an endless symphony. And still, that whisper contains our nearest hopes, our nearest worlds, our nearest mysteries. It is a reminder that greatness does not always demand distance. Sometimes the universe speaks most clearly from just beyond our cosmic backyard. As I reflect on these questions, I find a quiet lesson shimmering beneath them. A sense that curiosity is not simply a tool, but a calling. The more we learn about the stars near us, the more we learn about ourselves. We discover patience from the red dwarfs, resilience from the planets they scorch and shelter, humility from the distances we cannot yet cross. And most of all, we discover wonder, the kind that slows the breath, softens the mind, and lets us drift, just for a moment, in the quiet sea of stars, in the quiet river of starlight that flows beyond our sun. The nearest systems to Earth drift like lanterns on a cosmic lake, each holding a fragment of our galaxy's long memory. Astronomers often remind us that proximity in space is not the same as closeness on Earth, for even the nearest stars are separated by gulfs so immense that light itself needs years to bridge them. Yet there is a strange intimacy here, a sense that these neighboring suns are our first stepping stones into the greater night. Carl Sagan once said that to discover the world is to figure out where we are. And as we drift toward Proxima Centauri, we begin to understand how profoundly true that is. Proxima Centauri glows like a tired ember, the dimmest of the 3 stars in the Alpha Centauri family. And yet it is the closest sun we have, just over 4 light-years away, a distance so large it bends the imagination, but close enough to awaken possibility. Its small planet, Proxima b, circles in a tight orbit, the star's faint red light brushing its surface like the last warmth of evening. And for a moment, we wonder if life could bloom there. Stephen Hawking once remarked that the human spirit is driven by curiosity, and it is precisely that curiosity that keeps Proxima b in our dreams. Not because we are certain it harbors life, but because it reminds us that life might exist in more forms and more distances than we yet understand. The flares of Proxima make its world fragile, perhaps stripped of atmosphere. But fragility itself is a lesson, a quiet reminder that habitability is a delicate balance. Flowing outward, the light shifts. And Alpha Centauri A and B appear together like twin hearths burning at the edge of night. Their golden glow feels familiar, warm, steady, very much like our own sun. and that familiarity touches something deep within us. Here are two stars locked in an ancient dance, circling one another with a grace measured in decades. Their orbits slow and patient, like the breath of time. Astronomer Natalie Batalha once said, "Every star is a story," and Alpha Centauri tells a story of stability, longevity, and the possibility of Earth-like worlds beyond our reach. Worlds that may yet emerge from the glare when future telescopes sharpen their gaze. In this system, life does not feel like a distant abstraction, but a quiet promise. Then the light dims once more, slipping into the muted red whisper of Barnard's star. A small ancient sun racing across the galaxy with unmatched speed. It is old, perhaps as old as the early chapters of the Milky Way itself. And its planet, Barnard's star B, drifts in a cold twilight, far from the warmth needed for surface oceans. Yet this frozen world reminds us that habitability can hide beneath ice, that geothermal warmth, chemistry, and time may weave possibilities unseen. As astrophysicist Sara Seager once said, "The universe is under no obligation to make sense to us." And Barnard's star is a perfect mirror of that truth. A system simple on the surface yet mysterious in its silence. The path darkens still as we drift past Wolf 359. A star so faint that even the night seems to swallow it. A small ember hidden in the velvet of Leo. Here, the universe whispers about how common these red dwarfs truly are. How 3/4 of all stars are this small. Quiet. Almost invisible. Their subtle glow teaches us humility, reminding us that visibility is not significance, and that the galaxy is built not of giants, but of countless tiny lights. No planets are confirmed here. Only possibility. But possibility is the seed from which discovery grows. Then the night brightens again. Suddenly. Overwhelmingly. As Sirius rises. Brilliant. Cold. A beacon of white fire etched into human memory for thousands of years, Sirius A blazes like a young flame, while Sirius B sits beside it, a dense white dwarf, the collapsed heart of a once massive star, a diamond of degenerate matter bound by quantum pressure. Richard Feynman once remarked that nature's imagination is greater than man's. And nowhere is that imagination clearer than in a white dwarf, where atoms are crushed so tightly that a teaspoon outweighs mountains. A reminder that the universe shapes matter into forms both elegant and extreme, but the cosmos softens again as we drift toward Ross 128. A quiet red dwarf, unusually calm, holding one of the most hopeful worlds we know. Ross 128b. Here, the storms are muted, the radiation gentler. The planet warmed just enough to fall within the star's precious band, where liquid water might flow. It is still only a whisper, a possibility wrapped in darkness. But possibility is the ember from which entire civilizations of thought arise. Life finds a way. Ian Malcolm once said, and though he spoke as a character in fiction, the sentiment echoes through the halls of astrobiology. Gliese 581 waits further still, wrapped in controversy. Its signals debated, its planets argued over for years. A reminder that science advances not through certainty, but through humility. For a brief moment, Gliese 581 grams was hailed as Earth 2. Then skepticism washed over the discovery like a tide. Yet such tides are healthy. They keep the foundations strong, the claims honest, the search sincere. And perhaps that is the deeper lesson here, that wonder must walk hand in hand with caution, and that the pursuit of truth is a journey of revision, not arrival. As we drift outward, the stars grow thinner, the dark wider, and we realize that our entire journey has only spanned 20 light years. 20 light years. In a galaxy 100,000 light years across. A stroll across a single grain of sand in a beach made of starlight. Yet this tiny bubble, this local bubble, is where our story begins. A shell of warm, rarefied gas carved by ancient supernovae. A cradle for the sun. A neighborhood that shapes our skies. Neil deGrasse Tyson often notes that we are part of this universe, and the universe is part of us. And here, floating in the quiet between the nearest suns, that truth settles softly into the mind. What I take from this journey is simple, yet profound. Nearness in the cosmos is measured, not just in distance, but in meaning. Each star teaching us something different about ourselves. Proxima teaches vulnerability. Alpha Centauri teaches familiarity. Barnard's star teaches endurance. Wolf 359 teaches humility. Sirius teaches brilliance. Ross 128 teaches hope. And Gliese 581 teaches caution. Together, they remind us that exploration is less about crossing space and more about expanding the boundaries of wonder. And so we drift onward, unhurried, guided by the soft glow of nearby suns, letting science become a lullaby, and the universe unfold like a long and gentle dream. As our gentle passage through the nearest stars drifts toward its quiet end, we return carrying a softer understanding of the cosmic neighborhood that surrounds us. These nearby suns, bright or dim, calm or restless, stand as reminders of fragility, endurance, mystery, and hope. Proxima offers its whisper of uncertainty. Alpha Centauri warms us with its familiar glow. Barnard's star stretches our sense of time. Ross 128 holds a quiet promise. And even the disputed signals of Gliese 581 remind us that truth is a wandering path. Through them all, we learn that curiosity is not only a scientific desire, but a deeply human one. A gentle light that guides each step across the vastness. Every question we ask becomes a lantern. Every discovery, a widening shore. Every night sky, a reminder that wonder is our oldest companion. Thank you for drifting with me through this quiet corner of the galaxy. For listening, for feeling, for staying curious. Your presence brings warmth to this long cosmic night, and may your thoughts continue to float softly between the stars.